Okay, so let's dive right in. We make hundreds, maybe thousands of choices every single day. But have you ever really stopped to think about what's going on in your head when you do? We all like to think we're in the driver's seat, making these super logical decisions. But are we? Today, we're going to look at the user's guide to the so-called rational human, and more importantly, some of the really surprising bugs in our own system.
I mean, think about it. Why did you choose coffee over tea this morning? Why are you watching this right now instead of something else? The simple answer, the one we all kind of get, is that you wanted something and you believed a certain action would get it for you. Pretty straightforward. This basic formula, desire plus belief equals action, is the absolute bedrock of how we make sense of human choice.
And this intuitive idea, it actually has a name: folk psychology. It's the story we tell ourselves to explain why we do what we do. But it's not just common sense. It is the literal starting point for how economists build these massive, powerful models to predict our behavior. They give it a much more formal and way stricter structure. So how do they do that? How do they build on this? Well, they can't really build a science on vague feelings like wants. It's too messy. So to make it work, they take our chaotic inner world and they distill it down into something much more precise: a system of preferences. And this is a really crucial distinction here. See, a desire is absolute. I want coffee. Simple. You could also want to be healthy, and those two things can clash without you being illogical. But a preference, that's a comparative ranking. It's you saying, all things considered, I prefer this over that. It forces a clear order and lets economists map out exactly what we value. Now, for this whole preference system to be considered rational, it has to follow two basic rules. First is completeness. This just means if I give you two options, any two options, you have to be able to rank them. You can't just say, I don't know. And second, transitivity. And this one is all about logical consistency.
Transitivity seems incredibly obvious, right? If you prefer A over B, and you prefer B over C, then of course you have to prefer A over C. It's just basic logic. But, and this is a big but, if your preferences aren't transitive, if they run in a circle, you basically open yourself up to a really weird and very costly kind of exploitation.
And this brings us to the famous money pump argument. Just imagine someone whose preferences are circular. A clever person could come along and sell you your preferred option for $1, then sell you your next preferred option for another $1, and then because your logic is broken, sell you the original thing all over again. You'd end up right back where you started, just with an emptier wallet. Transitivity is what saves us from becoming human ATMs. Okay, so this whole rational model, it works great when we know the outcome of our choices with absolute certainty. But let's be real, how often does that actually happen? What happens when we're making decisions in the dark, when we have to deal with risk and uncertainty?
Most of our big, important decisions aren't these clean-cut choices. They're gambles. Like this party scenario, right? The best choice completely depends on something you can't control, the weather. So to handle this, economists model these kinds of choices as lotteries, where every possible outcome has a certain probability of happening.
Now, to make this model of risky choices actually work, we need one more really important rule. It's called the independence axiom. It sounds a little complicated, but the idea is actually pretty simple. It says that when you're comparing two gambles, you should totally ignore the parts of the gamble that are identical in both. Just cancel them out and focus only on where they're different.
Okay, so now we have our full framework. A rational person has complete transitive preferences, and they follow this independence rule when there's risk involved. And this elegant theory is used to explain everything from the stock market to insurance. It seems so logical, so robust, but let's actually put it to the test with a simple choice.
All right, have a look at this first scenario. In choice A1, you get 1,000 euros. Guaranteed. It is a 100% sure thing. In choice A2, you have a high chance of getting that same 1,000, a 10% chance of getting 5,000, but there's also a tiny 1% chance you walk away with nothing.
So what does your gut say? Just take a second. Which one feels right? If you're like most people, you lock in the sure thing. You take the guaranteed 1,000 euros. You choose A1. It just feels safer, right? Okay, lock in that choice.
Now let's try a different one. In A3, you get an 11% chance of winning 1,000 euros. In A4, you get a slightly smaller, 10% chance, but the prize is much bigger, 5,000 euros. And notice, there's no sure thing anymore. This is a pure gamble either way. So what do you pick here? Well, since there's no certainty to hold on to,
the whole game changes. Most people in this situation decide to go for the bigger prize. That tiny drop in probability seems worth it for a shot at 5 times the cash. They pick A4.
So, let me guess. Did you pick A1 in the first round and A4 in the second? If you did, well, your choices are totally normal, perfectly intuitive, and you've just walked straight into the famous all A's paradox. Because according to the rules we just laid out, that combination of choices is completely irrational. You violated the independence axiom.
Okay, wait, how is that possible? Let's break it down. Remember the independence axiom? It says you should ignore the parts that are the same. In both pairs of choices, the 89% column is the same in the background. So if you just mentally cross that out, the choice you're left with is exactly the same in both scenarios, but we don't choose the same way. That powerful pull of certainty in the first problem completely changes our strategy. It suggests something emotional, like a fear of regret, is messing with the pure logic.
And look, this isn't just some fun little brain teaser. This points to a huge problem for economics. How can this theory of rational choice be the foundation for so much if our actual, real-world behavior is constantly breaking its most fundamental rules? It creates a massive dilemma.
One way economists try to save the theory is by leaning on another rule called the invariance principle. And this basically states that your preference between two things shouldn't get all messed up just because a third, totally irrelevant option shows up. The context shouldn't matter. And there's a famous story about the philosopher Sidney Morgan Besser that illustrates this perfectly.
So this philosopher is ordering dessert, and the waitress says he can have apple or blueberry. He picks apple. Simple enough. But then she comes back and says, "Oh, we also have cherry pie." And he replies, "In that case, I'll have the blueberry." It's hilarious because it's so absurdly illogical. The existence of cherry pie is completely irrelevant to his choice between apple and blueberry. Nothing changed about those first two options.
But this raises a really tough question. Is context always irrelevant? Think about this. You're about to order a steak over the chicken. Then the waiter says the amazing prime rib special just sold out. Suddenly, the steak doesn't seem as good. Every bite might taste like disappointment, like the ghost of the prime rib you missed. So you switch to chicken just to avoid that feeling of regret. Is that really irrational? It feels pretty human.
And this is the core of the dilemma. Economists can either stick to their guns, stick to the formal, elegant theory, and just label all these common human behaviors as irrational, or they can start allowing for context, for things like regret. But the second they do that, the theory loses its beautiful objectivity. The economist has to start deciding what context is relevant, and the whole clean, universal model gets really subjective and messy really fast.
So it leaves us with this incredible question to think about. Are we humans just buggy, irrational computers constantly making flawed choices that break all the rules of logic? Or is it possible that the software, the economic models we've designed to understand ourselves, are just not sophisticated enough to capture the complex, messy, and maybe even beautiful reality of our own programming?